So in oscillatory motion, one special kind of motion is there, that is simple harmonic motion. So how we can get the simple harmonic motion equation? See, we have the force equation in previously F is equals to minus kx to the power of n. If I put n equals to 1, then the force equation becomes as a F is equals to minus kx to the, so minus kx. Okay, your power is n equals to 1, then force becomes as F is equals to minus kx. Now this type of force equation, so if the force is working, this type of force is working on the object, that oscillatory motion becomes as a simple harmonic motion. Okay, if force equation is F equals to minus kx in oscillatory motion, then that oscillatory motion becomes as a simple harmonic motion. Okay, simple harmonic motion. Now simple harmonic motion is very important for our JE as well as NEET. Okay, right. Now we will get the questions mainly from simple harmonic motion only. Okay, so we'll get the questions from simple harmonic motion only. Right. Now we know from the Newton's second law what is F is equals to, from Newton's second law F is equals to ma. I'm writing F is equals to ma in this case. Now ma is equals to minus kx. Then where a is equals to, what is a from this equation? A is equals to minus k by m into x. Now we are getting the a and x relation in this case. What is a here? Acceleration of the particle. So here force is working on the object. If force is working, ultimately we will get the acceleration for object. Now we are getting force, so from force equation we are getting acceleration displacement relation. We know, so in mechanics, if you want to solve any type of motion, we have to get the relations between force and time, acceleration and displacement, as well as acceleration time, as well as velocity time, as well as these type of equations. If you are getting this type of equation, you can solve the motion of the object very easily. Here we are getting acceleration displacement equation. We can find out the remaining all the equations. What are the velocity time and displacement time, as well as velocity, displacement, all those equations we can get from this equation in this case. Right. Now this is your force equation. So this is your acceleration equation for the simple harmonic motion. A is equals to minus k by m into x. Okay. So in this case, if you are observing about the motion of object in this case, if I am putting x is equals to positive, x is positive. If x is positive, then what happens? Your acceleration becomes as a negative in this case. If acceleration becomes negative, then simply we are just previously we observed in previous case we observed in this case. So how the forces are working in this case. So the same situation here also we can observe. Why? Because simple harmonic motion is a special kind of oscillatory motion. So the same thing we are here also we can observe in this case. Okay, right? Now if I am observing about the one of the object, so if it is making simple harmonic motion and it started from one of the position in this case, this is the position if it is started. When it is starting, its velocity I am taking as a v equals to 0. If velocity is 0, initially the velocity is 0, and due to this force F is equals to minus kx, the force is trying to pull the object towards this direction. If force is pulling in this direction, then what happens? Your velocity becomes increases continuously. Why? Because the force is trying to pull in this direction. So your force is pulling in this direction, and its velocity is negative or positive in this case. So ultimately it is negative. Why? Because the object is trying to move in the negative region of x. So velocity is negative in this case. Velocity is negative, and acceleration is negative or positive? It's negative only. Why? Because your x is positive. X is positive in this region. If x is positive, acceleration is negative. So negative velocity. So due to this negative acceleration, the object negative velocity is increasing in this case. So now both are, the magnitude of velocity, now we are observing about the magnitude of velocity. Magnitude of velocity, that is nothing but speed. The speed is increasing or decreasing in this case? Initially it is 0. Due to the negative acceleration, the negative velocity is increasing. Ultimately the speed of the object is increasing continuously. Okay, the speed of the object is increases. So speed of the object is increases when it is moving towards this direction. Okay, and next one, so what about the magnitude of acceleration? So here x value is decreasing. When object is coming towards this direction, x value is decreasing. If x value is decreasing, acceleration, magnitude of acceleration will be decreases. When object is reached at this mean position, then what happens? Acceleration, x becomes as a 0, acceleration becomes as a 0, and velocity becomes as a, magnitude of velocity becomes as a maximum at mean position. So v becomes as a maximum at mean position, acceleration becomes 0 at this position. So ultimately we can observe one thing, at this position acceleration, the x displacement is more and acceleration is more at this position. Acceleration is more and velocity is 0. This position, at which position the velocity is 0? Right, at this position the velocity is 0 and acceleration is maximum, and it's so that's way, so the acceleration is maximum, so velocity is 0, displacement is maximum. This position, so we can also call it as extreme position of your particle. Okay, so extreme position, the displacement of the particle is maximum, velocity is 0, so and acceleration is maximum, extreme position. So like that we have the two extreme positions in this case. Okay, right, object is coming in this direction. After reaching this position, velocity of object becomes as a maximum here. Okay, so velocity of the object is becomes as a maximum, and next one simply is the speed is maximum in this case. Okay, right, and next one, if it is entered into the negative region, then ultimately the force direction will be changes. Initially the force is in this direction, now the force is, so force direction is changed. Why? Because so x is negative. If x is negative, then what happens? Force becomes as a positive in this case. So force becomes as a positive. So now forces are working in this direction, but object, due to the inertia, it is having some velocity. So here maximum velocity is there. Due to inertia, it is trying to move in this direction continuously. Okay. So but due to this force, due to positive force, so the negative velocity will be decreases continuously. Okay. It is a positive force. The negative velocity decreases when it is moving towards this direction. The velocity continuously decreases, so the magnitude of velocity decreases continuously, and after reaching of this position again becomes as a 0 in this case. Now acceleration, positive acceleration. Why? Because positive force, acceleration is also increases in this case. So in this region the speed, so the velocity magnitude, the speed is decreasing due to the positive force. And next one, acceleration is increasing in this case. Okay, after reaching this position, velocity becomes as a 0, acceleration becomes as a maximum, and so force is working in this direction. The displacement of the particle is also maximum. This is also called as a second extreme position. This is your first extreme position, and this is your second extreme position. Okay, what is the condition for extreme position? Velocity is 0, acceleration is maximum, and displacement of the particle is maximum in this case. Okay, and next, now so this force, after reaching this position, this force again try to pull the object towards this direction. Okay, it's trying to pull in this direction. Now again velocity of magnitude again increases continuously, the magnitude of velocity again increases continuously, acceleration again decreases in this case. Okay, acceleration decreases again. After reaching this position, velocity becomes as a maximum, acceleration becomes as a 0, and it's repeated this path continuously. So to and fro. So this is the motion of simple arm. So this is your motion of the object. This type of motion is called as a simple harmonic motion. So what is the main condition for simple harmonic motion? The force equation is F is equals to minus kx. The power of x is 1 in this case. In oscillatory motion, the power may be 1, 3, so 5 and so on, but here the power is only 1, so that's your simple harmonic motion in this case. Okay, right? So this is your simple harmonic motion, right? Okay, thank you. So thank you. Okay, right, now with observation of this motion we can define, so we can give the one definition for simple harmonic motion. What is that? See, the first thing we are observing about the acceleration always working towards the mean position only. So in this case, So why? Because the force always working towards the mean position. So that's why we can conclude that acceleration always works towards the mean position. That's the first conclusion. And next conclusion, so your acceleration, so A is equals to minus k by m into x. So your acceleration, if I'm taking this is the constant, so k is constant ultimately, and mass of the object is also constant. So if I'm removing this, I can write A is directly proportional to x in this case. So but minus is there, so A is directly proportional to minus x in this case. So that is your second conclusion in this case. Okay, and next one, we always find out the displacement. So displacement of the particle from reference position. Okay, so by generally in books, the simple harmonic motion definition is gives based on these three conditions only. Now, what is the ultimate definition for simple harmonic motion? So, if object is follows the A is directly proportional to minus x condition, and the force always working towards the mean position, and displacement always so find it from the mean position. Displacement of the object always finds so from mean position, then we can so call it as a simple harmonic motion. So the conclusion is nothing but if any object is making simple harmonic motion, it should be follows the three conditions. What are the three conditions? So the first one is it should be periodic motion. It should be periodic motion. See, ultimately it's oscillating motion. Oscillating motion is nothing but periodic motion only. Okay, it should be periodic motion with a fixed time interval. And next one, acceleration always directly proportional to so displacement, and both are in opposite direction. This minus indicates that both are in opposite direction. And next one, acceleration always works towards the mean position. Okay, this is the basic things of the, so this is the basic explanation about the simple harmonic motion. So thank you. So okay, so
simple harmonic motion excellent.